Hello everybody, Peter Gilroy here, and today I am going to be doing a presentation um, that was done originally for the 2017 Santa Fe Symposium. Phil Poirier and myself wrote a very extensive paper all about using dyes, creating dyes, and the quest for fine detail. So I'm going to go ahead and give this presentation showing you all the different aspects of this, and then I'll also have a link below and on the website for the original paper, which has even more info than I show here. Um, so we often get asked when working on the hydraulic press, how do we get finer detail? How do we get crisper lines, crisper edges in our forms? And so really the short answer to that is working with hardened tool steel dies. And this paper is all about that, covering all different aspects of that. So let's go ahead and get started. Here's a collection of antique hobs made between about 1870 and 1830. And these are all really amazing, beautiful works of art that were hand engraved and chased and carved and used in factories in Providence, Rhode Island. And we have a whole bunch of these, and it's really interesting what we can learn from these. But you can see a lot of artifacts of grinding wheels, files, chasing, and other stuff like that with how these incredible master craftsmen were creating these dies. So before we get into stuff, first of all, what are the advantages of die forming and cold working metal? For one, we get to work with thinner metal and get really high quality out of it. So casting does have a limit. With die striking, we can work with very thin metal and get really good strength. Because of the cold forging of the grain structure on these die struck pieces, we get excellent surface finishes and we get incredible strength and hardness in the finished product. And we'll go into that in a little bit more detail explaining why. But in short, it creates pieces that are really easy to clean up, crisp, sharp details, and they can be finished very rapidly. Um, why are we using a hydraulic press? Uh, for one, it is the most economic, safe, easy to use type of press on the market. There are lots of different presses, punch presses, knuckle joint presses, other mechanical presses, but the hydraulic press, full power, anywhere within its stroke. It's cheap, it's easy, and it's very flexible. We can set up and do everything from forming a bracelet in a ring to doing deep draw to doing die striking, all with one simple small press that fits on your bench pretty well. They also are some of the safest types of presses on the market. So yeah, hydraulic presses, really amazing. The when I talk about dies, I always talk about it being a sandwich. Our piece of metal, our jewelry, our finished jewelry is the meat of that sandwich that's in the middle, sort of shown here as this piece of gold. And then we have a bread of our sandwich is always going to be the die. So in this case, a non-conforming die. We have either a steel, aluminum, or brass die. Doesn't have to be hardened for most non-conforming. And then we have polyurethane, and the polyurethane is essentially just bending that metal over the peaks and valleys. Now, a conforming die set is essentially the same thing, but instead of the polyurethane, we are using a steel die, and that results in more pressure getting put into the metal and better, crisper corners, sharper edges, better detail, and stuff like that. The second, or I guess in this case, the third types of dies is going to be a coining die, whether that is a single-sided die and the top piece of bread is going to be just a flat hardened steel punch. All coining dies really need to be hardened. The pressures that we're using in coining would deform even a steel die unless it's hardened tool steel. So these are all going to be hardened tool steel dies and single-sided or double-sided like you would see in a coin. And coining is really the highest level of detail. When we are working with conforming dies, we're getting some forming, but also a little bit of coining. So working with very thin metal conforming dies are the absolute best. Coining dies work really well with thicker metal. Here's a cross-section graphic explaining grain structure. So when you cast an ingot and mill out a sheet, or if you buy a sheet metal from a big supplier, essentially you get this nice long linear grain that's really quite strong as it is here. If we were to go and now reductive machine or carve away that metal, you can see here that we still have that long linear grain, but in some of the thinner points, you get a little bit weaker areas. Now with die striking, which is what we're showing here, C is this would be a conforming die striking this little piece, is that grain structure is now follows along with the piece, resulting in a lot more strength and very fine grain structure that's going to be very strong and very easy to polish. And this last piece here is showing kind of what a cast grain structure might look like, where it's a crystal matrix and it doesn't really go along with the piece at all. So cast pieces are always going to be the weakest. And that's really the beauty of die striking and working with the press is we get these really strong pieces because of just the grain structure manipulation through the technique. Here are some actual cross sections of 3 different techniques. So the first process that we're looking at here is using a non-conforming die with polyurethane to press probably 20, 18 gauge metal here in this little flower. And it's got okay form, but the polyurethane is never really going to get the strength and put the pressure into the metal enough to fully form the finest details. If the big broad shapes, non-conforming dies work great, but in an example here, doesn't really get it. Example B is where we're now using a conforming die, so the positive and the negative, and you can see that nice sharper details. It really gets the form much, much, much better. In example C here, we are using coining. So coining requires thicker metal. It does yield the highest level of detail by far, but requires thicker metal. So oftentimes the difference between using a coining die and a conforming die depends on what I want the back of my piece to look like and how thick of metal I want to use. So throughout this quest to get finer detail, we created a set of detail dies so that we can compare the effects and kind of help to illustrate some of the variables such as thickness of metal, the way the die is used, so that we could kind of measure and quantify how detail shows up in our metal. So these were both done in tool steel with various sizes of lines, circles, squares, diamonds, just to give us a good idea of, how much detail shows up. Down below here we have 2 coin samples. This one on the left was done in 12 gauge sterling silver that was annealed, so a nice thick reservoir of metal is what we like to use for coining. And then here on the right was 22 gauge annealed sterling silver. And this really illustrates the difference in coining of how much detail you can get with an appropriately thick piece of metal. So here on the 12 gauge sample, you can see every crisp little edge and detail that is in the die. However, on the 22 gauge, you just get these very subtle little puffed shapes, kind of similar to a silhouette die, because the metal, even with another 150 tons of pressure, this 22 gauge would not flow down into the die and get it nice and crisp and sharp. So these were 2 non-conforming die samples done with our high precision die container and that sample die that we made. And this is showing the difference between different thicknesses of metal. The thinner the metal, the easier it's going to form over a said die. The thicker the metal, the stronger essentially it is, and it's not going to bend into the peaks and valleys of our die as well. So both of these were taken to 55 tons, 30 gauge on the left, 18 gauge here on the right, and this really illustrates well the difference. And again, in this 30 gauge, using polyurethane to press it in there, 55 tons, we get a lot of detail. Not quite as good as coining, but for 30 gauge, it worked quite well. 18 gauge, you can't even see some of the lines, and some of these smaller shapes are just faint little outlines. So it really leaves out a lot of detail in my finished piece. So non-conforming dies, generally, they're going to work best with thinner metal. The more detailed the die, the thinner the metal is going to be required to get all of that detail. All right. So we came up with this little chart to kind of help illustrate all of the different ways for you to make your own die. And this is partially going to depend upon what your skill set is and how you like working. So first of all, everybody, we all have to start with a sketch. Got to get a good idea of what we want our finished product to look like. I always say we need at least plan and elevation view, and we need to look at the volume and the details and all the little, elements that we want to put into our finished piece. Then, once we get a good sketch, the kind of simplest way is going to be directly carving into metal, whether that's engraving, chasing, or using rotary tools to carve directly into tool steel, and to create our finished hob and die. Also, we'll talk very briefly a little bit about carving into copper and graphite and using electro displacement machining for creating a tool steel die. If you are a really good model maker, if you like working in clay or wax or wood, you can create a model, and then you can take that model, you can 3D scan it, and that will give you a computer drawing that you can then take and utilize for making a die with a CNC mill. There's also a really cool machine called a reducer replicator where you can take your model, cast it in a hard resin, and now use it on a reducer replicator for cutting your die into tool steel. And there's a couple other variations on here. I also sometimes use a combination of these techniques. So this is a really cool example that Phil Poirier did, creating a master model in wax, and then using a reducer replicator to cut this finish hob and this die, and to create these really beautiful pair of 18 karat gold earrings over here. So here's a short clip of this is cutting a wax using a ornamental rose engine lathe. Really fun machine. Can do some really cool patterns and really limitless in what it can create. So once that wax is created, now we painted it with a conductive silver paint, as shown here, and hooked it up to some electrodes in a copper plating solution. And essentially this is called electroforming or electroplating. And we left it for a very long time in order to build up a very, very thick layer of copper. This was roughly 1 millimeter thick when we were finished. And this gives us a exact replica result of our carved waxes. So here's a few different models that we worked on, and their copper models that we electroformed or electroprinted. So now once we have these molds, essentially we can chuck them up on the reducer replicator and cut a die in tool steel. And this is just a stylus, a tracer in the reducer replicator. This is a example of a modern reducer replicator. A lot of them were made way back in the day. This company is still making them. They're also known as a medallion machine or an automatic engraving and reducing machine. So they are designed to take a model, trace it, and then cut it at a smaller size with incredibly fine detail into a block of steel, creating a finished die for stamping. So you can see here, this is probably a resin model on the right, and then this is the finished die of some very large medallion. This is a good video showing the copper piece being traced and then now here being cut. Here's a little schematic showing. So essentially what we have is this large toolbar that pivots right over here. The tracer on the far side is following our model. And then here is our cutting spindle and our piece of tool steel that we are cutting our die into. Now where I move this chuck, if I move it towards the pivot point, I can create a smaller and smaller die. If I move it towards the model, I create a larger die. One of the beauties of working with the reducer replicator is all of the detail that is here is scaled down in the finished piece. So you get really super fine, incredible detail using something like a reducer replicator. Here's a time lapse showing the tracing spiraling out along this model. So it has a very, very small step over, creates a really nice clean cut. So a typical time to create a die like this is roughly 3 to 4 hours, and we'll usually do multiple passes. So using a reducer replicator, it takes time, but it's all automated. And so once you set it up, you just go ahead and let it run, and it'll turn off automatically at the end of the cycle. Now we can see here the finished hob that was cut, and this nice little very fine point carbide cutter is shown here, and that's what's cutting our die. And again, that's the finished example. So this die was cleaned up, it was hardened and tempered, and then it was pressed into softened tool steel to create the mate. And then therefore to create these 18 karat gold earrings. And again, these were probably 22 gauge, 24 gauge, 18 karat gold. So didn't take a whole lot of material to create these really incredible, powerful earrings. Here's an example that was provided to us by Anthony Lent. He's an incredible artist, and he sculpted this snake out of clay, including a place for a bezel in there. Then a mold was taken from the clay using a silicone molding material, and then cast into that silicone mold is a hard epoxy. This gives us a very durable and hard model to use in the reducer replicator. So this original piece was about 8 inches from tip to tail. And then when run through the reducer replicator, it ended up being only about 1 inch from tip to tail. So again, all that detail that you see here was scaled down really beautiful into this finished piece. All right, EDM doesn't stand for electronic dance music in this case, it's electrical discharge machining. And this is where we use an electrode. In this place, it is copper, and that electrode uses a very specific constant voltage to slowly eat away at this tool steel. So again, this is one of the waxes that we carved, electroformed into it, and then used this piece to cut our finished die. And here you see is our finished silver piece. One of the beauties of this is you can use this technique directly into hardened tool steel. All right, so path number 1, this may be one of my favorites, but this is hand carving directly into tool steel, and it's really not that difficult. It's a lot easier than people ever think it is. Got to give yourself some time to get used to it, but this was used, essentially I used a big grinder to just remove the outside. And then working with files and ball burrs, I shaped and refined this piece little by little. Various burrs, silicone abrasive wheels to clean things up, to smooth things and polish them. And that's it. So one of the things I like about working in steel is that it's a little bit slower, but I feel like it gives me much better control, and it gives me the ability to create much finer details and control the process better because it is a little slower. So everything starts with a sketch. All right, so everything starts with a sketch. This was the original sketch I did for this next project we're going to show. And first started out with a plan view of a wild rose. Just a quick, simple little rough drawing, highlighting some of the things I wanted. I wanted textured inner petals, and then I wanted these rolled up outer petals to be nice and polished, giving me some good contrast. Here I drew a side view, and these are going to be earrings, so kind of played with what, okay, the post is going to be coming off here, and I want these petals to all twist, so I have them taper towards one side. And then looking at a cross section, you see this sort of rolled up portion of the petals, and then this nice sharp hard corner here leading to the textured inner petals. And then the final piece we'll see, I went ahead and I drilled a hole in the center, set a little tube, soldered it in place, and set some sapphires in that. So part of the reason why it's so important with the sketch is to start understanding all these different variables, what you want to create in the metal. If you don't have a sketch, it's going to be really hard to control the process, and you're going to end up, not taking away too much metal or not enough. So here is roughly the first step. So I used a metal scribe to just go ahead and trace out the petals of the wild rose. I wanted them to be organic and not even. So this I just did all by hand. First of all, I started with the ball burr, and I just started removing the outside, going in here and profiling my piece. And I'm working with annealed, softened tool steel. So yeah, no, you couldn't carve this directly into hardened tool steel, but with annealed tool steel you can. Using just normal ball burrs, nothing great, nothing super cheap, but just they don't have to be carbide. High speed steel ball burrs work just fine for this. Using burr life or a lubricant of some kind does help quite a bit. I always tend to start with bigger ball burrs and sort of work out the most of the volume, and then step my way down smaller and smaller and smaller, refining the details, refining sharp edges, and bringing it kind of all into focus, if that makes sense. So yeah, this here is roughly maybe a 2 mm ball burr, and then on the right we're working with a 0.5 mm ball burr, and I'll go down to ball burrs that are as small as 0.1 millimeters, or even smaller sometimes. Does help to work under a microscope. When I did this die, I didn't own a microscope, so I just did this with an optivisor. But now I choose to do all this work under a microscope. Just gives you a lot better resolution of what you're working on. So got the texture added in there with tiny little ball burrs, got all of the main shape put together, and then here I'm just using a silicone abrasive wheel to smooth and polish the outsides of these petals. Contrast always helps in dies. Anything you can do with varying textures will give you the idea of having more depth and kind of a little bit more dynamic of a piece. And then you can also experiment with different types of burrs. So in this case, I was using a cylinder burr to do some of the sharp edges, going back with a ball burr to rough out the shape here, and just slowly working it little by little. One of the benefits is you're working in the positive in this case. So what your die looks like is going to be what your finished piece of jewelry looks like. And that's really, really quite incredible. It makes it a lot easier to work with. Super small ball burr texture in there. So on some dies, like if you were to create a non-conforming die, you are creating the negative die, and that's a lot more difficult to visualize. So this is why I like working in this method, because I can see what my finished piece is going to look like. All right, so heat treating tool steel. Now, again, in the paper, we get into a little bit more detail about this. But in short, we wrap our finished hob, our finished dies in stainless steel foil. This keeps the oxygen out of it and it keeps the die from oxidizing heavily in a hot kiln, or decarburizing is what we call it. So this keeps the oxygen off it, allows us to heat treat it. A2 tool steel, we heat treat to about 1750 degrees Fahrenheit using these Paragon programmable kilns that go up to 2000 degrees. You can heat treat dies all day long. And so once the hob is hardened, so we heat this up to about 1750 degrees, remove it from the kiln, let it cool in air. It's hard, but it's very, very brittle. So after we do that, we put it back in the kiln and we temper it twice for 2 hours at about 900 degrees Fahrenheit. This makes it a little bit softer, but it also makes it much, much tougher. So it's not going to just break. If you have really fine, crisp details, if the die is too hard, it's going to break. So a good tempering is really critical. Again, go check out the paper to get all those details about this. If you are working with different tool steels out there, something like D2 or A6 or O1, they're all going to have different recipes for heat treating. So we mostly work with A2. I really think it's the easiest and best to work with. If you're working with another material, you can look it up and get full recipes on how to work with it. All right, so once our die is hardened and tempered, we now get to press it into softened tool steel. This is a really exciting part where we now are creating the negative die. Surface finishes matter here, so this piece of annealed tool steel, we polished it very nicely so that there was no markings on it, and we get a really identical replica of our master hob. So in this case, we use about 65 tons of pressure to hob this die. And now this is going to give us, again, this is going to give us the mated positive and negative tool steel dies. All right, so here from the previous example of this little hand-carved wild rose, this is the finished hob. This was pressed here into the negative die, softened, and then we hardened and tempered this. Now we can use both of them together as a conforming die set. So I did do that with some 18 karat gold. Or we can use just this negative die once it's been hardened and tempered as a coining die. And so I did that for these pieces in sterling silver so that they would be nice and thick and substantial and be a lot stronger, make working with them a little bit easier. Here is showing just some of the ideas. There's really like worlds of possibilities with die making. This was the little heart that we showed in an earlier example that was just done with files and, polishing wheels essentially. And here we took it and we repeated it 5 times around in a piece of brass to create a non-conforming die of a little flower. And you can see here, this is what we use our non-conforming dies in. It's a high pressure container with a polyurethane that we're going to form our metal into. These are a couple of examples. Here is the one we just showed of the little petal leaf. This one we got a little bit crazier and just stamped a bunch of times, varying the spacing, so there was a lot of overlaps and it created this really cool looking flower. And again, both of these were pressed on a 20-ton press in 30 gauge copper. Silver would work as well. And here's just another example of taking a single element and then stamping it multiple times in a straight line. So there's a lot you could do with this. So many possibilities of creating your own dies in this way. And you can see here on the bottom, we laid out a little grid so that we could get the spacing pretty good on that. So with a single hob, we can create lots of different dies. And that's really one of the beauties of this whole process. This is kind of my signature texture, the granite texture, and this was done by hand filing and sanding these two little pyramids, a three-sided pyramid and a four-sided pyramid. And these are my two hobs. Now, I took these hobs and I stamped them repeatedly over a large block of softened tool steel and created this really dynamic, really fun, glittery texture. Especially when it's left bright and polished, it really plays with the light. Or here's an example of a ring I made with it. Stamped it in black niobium with 18 karat gold inlay and a nice little white diamond. So I think this is one of the techniques. There are literally endless possibilities, something you can do. You can make your own hobs really quickly, sitting at your bench, and then stamp out all sorts of various dies, different shapes, different textures, tons of possibility here. All right, path 2B. So this was a model that was carved for us by the incredible Kate Wolf. She's a really masterful wax carver, teaches awesome classes all about wax carving. And she carved this for us for this project. We took this and we sent it out and got it laser scanned. The laser scan company now sent us this really beautiful high resolution CAD drawing that we could work with in 3D for creating dies. Now, once we had that CAD drawing, we were able to run it through our CAM program and tell our CNC mill what we wanted to do with it. So here we're using an 1/8 of an inch carbide ball mill cutter, and we're roughing out the overall shape in steps. Then we're going to go back with smaller and smaller cutters and just keep refining, keep working on the level of detail in there. So here's our finished hob and our finished negative die. And in this case, we used the CNC mill to kind of rough out this negative die. And then we pressed our hob into it to get an exact replica, an exact mate of that die. And here's a piece of 26 gauge brass that we stamped out. All right, so path 3, CAD CAM, and this is an example of a bunch of dies that I've made, that Phil Poirier's made, just using 2D geometry. 3D surface modeling is a little more complex, and I tend to use a lot of 2D geometry to create these three-dimensional dies. And these were all CNC machined directly into softened tool steel and used as coining dies. So here is the CAD drawing. This is what I call my sandstone wave design. And this is all that the geometry entailed. So this was kind of sketched out, and then I went in and started sketching it in Rhino, the CAD drawing program that we use, and just kept refining it. Next, took it to a program called Visual Mill. This is CAMS, or Computer Aided Machining. And this program takes our geometry, and then we're able to tell it what kind of tool we want to use, how we want to cut, how deep we want to cut, how fast we want to go, etc., etc. And this allows us to really control what that final piece is like. So in this case, I'm just straight engraving with a 90-degree cutter and creating these sort of series of peaks and valleys with nice sharp edges on top and under and down into the die as well. And here's a quick little video showing some of this and showing the simulation. So I'm setting my total depth to 22 thousandths of an inch, about 1/2 millimeter. And now that shows the tool path, and here is an actual simulation. So oftentimes I will go back and forth between CAD and CAM and just keep working and refining this visualization until I get the final end product that I really want. So that is one of the beauties of working in this way. Sometimes it's a little hard to sort of feel the like size and details in CAD, but being able to visualize the die in this capacity really helps and makes it a lot easier to create that finished die exactly how you want it. Now, CNC machines and these programs are fairly expensive, and there's a big learning curve to getting set up. For me, it was something I knew I wanted to do early on, and that investment has been well worth it for making dies um, on my CNC machine, but also directly machining into silver, titanium, Damascus steel. So a lot of the jewelry I make as well is machined in this capacity. So it's a really fun process, and if it's something you're interested in, it's, well worth the investment. Also work with a company like us making these dies. We have the CNC equipment and we do make custom dies. You can also find local machinists in your area that can do work like this as well. Here's that finished coining die. This one has gotten a lot of use. And here on the left is our finished piece in niobium and 18 karat gold as well. So three-dimensional CAD. Now, if you're really good at CAD and at surface modeling, you can create really elaborate three-dimensional forms, and then you can CNC machine those, 3D print them. There's a lot of ways you can take that CAD design and work with it beyond, if for making dies. So this is simple curves and lofted surfaces, but creates this really beautiful fleur-de-lis. Um, I'm not going to go into surface modeling. There's a lot to it, but there's lots of resources out there. Good old YouTube, where we're at now, has so many things about 3D modeling for jewelry. Here we see a simulation of this die being made. Again, it's first getting roughed out with a larger diameter tool in steps. And then it's going to go back with a smaller tool and do a finishing cycle called parallel finishing, where it's going to create the final shape. And oftentimes one of the things I'll do is I'll create dies on my CNC machine, and then I'll go sit down at my engraving bench and engrave and chase and work the dies and add details and add textures that way. So that's where I oftentimes use a combination of these techniques. All right, and here you can see on the left some of the tool pathing that went into this piece, and then here the finished die that was CNC machined and then cleaned up a little bit. Again, this was hardened and tempered, pressed into a soft piece of tool steel here, and then the two were used together as conforming dies to create this nice little silver medallion. All right, safety. So working on the press, working with all these different dyes and materials, it's important to understand some basic material properties. Essentially, when you put any metal under stress, essentially under stress being you put it in the hydraulic press and you start squishing it, it is going to, first of all, elastically deform. It's going to deform a slight bit and then it's going to bounce back. Once you reach the yield strength limit, you're going to get plastic deformation. So the metal is going to, and this is what we want with our silver and our gold. We don't want plastic deformation with our dies. And so that's why we're making our dies out of hardened tool steel. And then we're working with formable metals like silver, gold, copper, because those plastically deform well. Now, if we were to take our dies way beyond plastic deformation, we get to the point of failure or fracture. And that is what we want to stay away from. Um, let's see a couple examples here. This is a piece of mild steel. It's about 65 tons of pressure here, and it plastically deforms very, very easily. So all material property is going to be a little bit different. our dies, when we're making our dies out of hardened tool steel, they don't plastically deform, and that's important for our finished piece of jewelry. You can see here, this is the piece we just saw in the previous slide at different tonnages, here taken to 100 tons of force. And this just kept plastically deforming up until that point. We also did this with 360 brass, which is a free machining brass, and we pressed it, and at about 70 tons of force here on the right, you can see it completely fractured. It didn't like explode, it didn't go flying out of the press, but it did crack when we stopped what we were doing right there. Now, the hardened tool steel will hold up to a lot of pressure, but if the dies are designed incorrectly, or they're not tempered well, or you're exceeding the pressure limit of them, you can break those, and those tend to break much more aggressively. So here on the left is one that we broke, hardened and tempered tool steel, and we broke this all in the name of science to see what would happen. This is a video of this breaking, and there you go. So when we were using this die with our metal to make jewelry, we only needed about 25 tons of force to get a really, really, really good, highly detailed example. This broke under 100 tons of force. And now the tip of this die is actually quite small. So the actual pressure at the tip of this die where it was contacting the other die, right in here, would have reached about 400 tons of force in order to break this. So we always say when we're working with dies, we use as little pressure as we need to get a good end result. And that just ensures we don't go way over the limits of our material properties. But, this is important to do, all in the name of science. All right. So here's an example from Anthony Lent, this really cool moon face that he did. Again, cut this on a reducer replicator. And here is the positive and negative die, the conforming dies that he used to stamp out these jewelry pieces. This are some examples of dies and finished pieces by an artist in Santa Fe, Doug Magnus. And these were sort of modeled after old Spanish coins, the pieces of 8 from the 17th century. And all of these dies were hand carved by Doug using micromotors, ball bearings, and flex shafts. And really, got some really excellent results out of this process. These are examples of some dies by Amayak Stepanyan. These were all hand engraved, and in order to really see all the details in here, you need a loupe or a microscope. So hand engraving is really incredible what you can do with it if you're, a master engraver. This another antique hob. This overall is just about 1.5 inches long. And you can see even remnants of saw marks and probably some chasing and engraving that was done all in here. You can see this little bit of chasing on these leaves to give it some texture and to refine the shape. So yeah, really incredible what you can do by hand. Takes practice, takes time, but I believe it's possible for everybody. Another example, these are some CNC machine dies that Phil Poirier made. This is, one of the pressed examples with a bezel soldered into it, and then the finished piece over here with a transparent enamel added to it. This is a hob that was designed by Maria Zamora, made by Phil Poirier, and then the matching die here to create this beautiful little piece. And so this was all machined out using a 32nd of an inch ball end mill. All right, so just in summary, there's a lot of different ways to make these dies. They're really quite incredible what you can do with die striking. And if you haven't, had a chance to play with this at all, I'll be doing more classes, more YouTube videos about this. And yeah, really incredible what you can do. So again, just a summary. Simplest path is going to be direct carving into metal using engraving, chasing, rotary tools. If all you have is a flex shaft and a bench pin, and you can sit down with your Optivisor and carve in steel, you can make some incredible dies. If you're a really good model maker, whether you're working in wax, wood, or clay, then you can make large scale models, very highly detailed, and either mold them and use a reducer replicator, or 3D laser scan them and then send them off to somebody to create the master hob through the whole CAD, CAM, CNC pathway over here. Again, if you're really good at doing CAD, whether it's 2D or 3D geometry, you can take your sketch and you can translate that into CAD, create awesome 3D models, and then, CNC machine that yourself, or again, send that out to somebody else. For example, we do CNC machining of custom dies, so that is a good option as well. There's a lot more ways to make dies than this. This was just sort of designed for the small studio. What are some of the techniques that you can get into? And I think there's a lot of other possibilities in this, some future experimentation. For example, this was a die that was made by Jim Binion. So he designed the dies in CAD and 3D printed them and then cast them in bronze. So here, then this was the positive and the negative conforming dies to create this little heart. There's other options, new technologies. I mean, things are developing so quickly, whether your laser cutting dies, laser sinting, essentially 3D printing directly into metal for dies, or using all sorts of different combinations of techniques. There's a lot of possibility out there. I will be getting into another presentation of a paper I did in 2018 that's outlining some of these more experimental ideas and getting into detail and die design a little bit more. So that will be coming up hopefully soon. If you have more questions, go to bonnydoonTools.com and check out. We've got this paper on there under the instructions. We've got a lot more papers and resources. And check out all of our videos here on YouTube. Don't forget to like and subscribe. Yeah, and thanks for watching, and see you guys soon.